SENS Foundation was created in 2009, and it was created because we felt that the Methuselah Foundation was suffering from having two activities, two themes that were, if you like, competing or at least diminishing each other in terms of the messaging involved. The Methuselah Foundation was originally created to administer the Methuselah Mouse Prizes, these prizes for beating the world record for mouse lifespan. And that was a very useful goal. It was something that we were able to use to raise the profile of longevity research among the general public, especially among people who, didn't really want to think about science very much. Science scares them, but who identify with, world records and prizes and stuff. But then when we started also to be a bona fide research funding body, an organization that actually sponsored specific research projects, we obviously had to be very different. We had to project an image of very clear, responsibility and expertise and so on, which is very much the opposite of that sort of glitzy populist approach that we were taking for the prizes. And we never really found a good answer to that. We never really found a way to square that circle and to get those two activities to complement each other in the way that we had hoped that they could. So eventually, after a bit of soul-searching, we decided that the best way was to have two organizations. And so we created SENS Foundation as a completely independent organization. And the Methuselah Foundation divested all of its research activities into the new organization. And the Methuselah Foundation went back to being predominantly the one that administers these prizes.
I think that's great that you did the soul searching on it and looked and were able to see what you needed to do. A lot of people see it, but they won't make the changes to do it. So congratulations to you on that.
Well, right, yes. There's one particular person who was our development officer at the time who really kick-started that, and I am, eternally grateful to her for doing that.
You have a background in computer science. Your wife is a biologist, and did she inspire you to get into biology, the biology of aging?
My wife is indeed a biologist, that's right. And when we met, I was, as you say, a computer scientist. I was not working in biology. I'd given up biology in high school at the age of 15. And I learned a lot of biology just informally, by accident, over the dinner table, over the subsequent few years. So in that sense, my wife did indeed inspire me to get into biology. However, not into the biology of aging. That was not an area of her interest. In fact, the reason why I got into it was largely because she was not interested in it. Or to be more precise, it was because not only was she not interested in it, but also I became aware that most biologists, almost all biologists, were uninterested in aging, regarded it as not a particularly interesting problem, not a particularly important problem. I was absolutely horrified by that. I couldn't understand it at all because it seemed completely clear to me that it was actually the world's most important problem in biology. But eventually, having, become aware that this really was the case, that there was nothing to be done, I felt that, my only option was to actually get involved myself.
Very, very exciting. What does she think of your work today?
Oh, she's pretty proud of me, I guess. She's still, it's not something that excites her and, gets her out of bed in the morning the way it does for me. But, yeah, she thinks I've done okay.
Why did you call SENS the Strategies for Engineering Negligible SENS Science? What does that mean?
Senescence. Yeah, okay. So the reason for that is a bit historical.
I figured.
It starts out from the phrase negligible senescence, which was a term coined more than 20 years ago now by a very eminent gerontologist named Caleb Finch. And he used this term to describe species that do not age. Or, to be more precise, species that, if they do age, they age so slowly that we can't tell by looking at a population and measuring how many there are of any particular age. So he defined negligible senescence in that way, negligible as in imperceptible, if you like. And so I simply coined the phrase engineered negligible senescence as the process of of turning a species that does age into one that doesn't, which of course is the goal here. And then, strategies just goes with that.
You remind me of Richard Branson of the rejuvenation biotechnology field. You sound as optimistic as he did for Virgin. I meant that in a good way, though. I meant it in terms of your passion and your commitment and your love in seeing this through. And
I have a very high opinion of Richard Branson, and I'm completely amazed that he hasn't already got involved in all of this.
I am surprised, too. I'm really surprised. I think he's still focused on Virgin Galactic and getting these flights out within the next couple of years.
Yes, he's not the only one. Quite a few of the more obvious supporters of all of this seem to be much more interested in rockets than they are in people's lives.
Well, we'll see what we can do about that. I think there's a lot of people that would be interested, and more people need to know about you. And I have one last question, and I really appreciate your time today.
Right.
That is, what do you think is going to be the direction of preventing cell loss? And could you explain to us why there's cell loss and what we do know about it today? Because I know it's one of your 7 deadly sins.
Sure. Cell loss is a fairly easy one to talk about. So why does it happen? Well, there are certain cells in the body which are simply not designed to be replaced. So they're designed simply to live for a very long time and hang out and not die throughout the whole of the organism's life, throughout the whole of the human being's lifespan. Fine examples of that are neurons in the brain. Most neurons simply are not designed to be replaced. And that's okay by and large. Most of the brain is a sufficiently well-protected place that there is very little in the way of cell loss. However, there are 1 or 2 parts of the brain for which that's not true. And there's a particular one called the substantia nigra in which the neurons create a chemical named dopamine, and the process of creating dopamine has side effects, in particular side effects that create toxic molecules that sometimes kill the neurons. So the rate of cell death, the rate of death of neurons in the substantia nigra is much higher than it is in almost every other part of the brain. And, of course, it varies from person to person. Some people have a higher rate of cell loss than others in that particular region. And the people who have the particularly high rate of cell loss are the ones that come down with Parkinson's disease as a result. So the question then is, as you say, what do we do about it? And the answer is very simple. We put the cells back. Or rather, to be slightly different, what we do is we put cells back that are the precursors, the progenitors of the cells that have gone missing. So we put the cells in, and they then divide and differentiate into the cells that we've lost. That's a process which works really well if we can do it. But we have to get the progenitor cells into just the right, what's called epigenetic state, just the right frame of mind so that they know exactly what sort of cell they're supposed to turn into. And that's tricky. There have, however, been a number of very good successes in this area already. There have been clinical trials of cell therapies for Parkinson's disease, putting cells back into this particular region that have worked really, really well. We haven't got it reliable enough yet. There are other trials that have happened that have not worked so well because, for whatever reason, it hasn't been done quite correctly. So there's still some work to do to figure out the fine details, but it looks very promising.
My mother passed away of Alzheimer's, and I had to watch many years of my mother turn into somebody else. Even though she was still her, I had to watch a very traumatic thing happen to my mother. And I know that Alzheimer's is on the rise. And I was wondering, do you have any ideas about how that may be prevented or stopped?
Right. Alzheimer's disease seems to be a much more complicated disease than Parkinson's. There are lots of things that go wrong in Alzheimer's disease. The accumulation of at least 2 different types of molecular garbage, one inside the cells and one outside, and also the loss of cells. And I believe that a cure for Alzheimer's is going to involve treatment, a multi-part treatment, including the elimination of all of these types of damage. Some of these things are going quite well, in particular the removal of the extracellular junk. It's going very nicely. There's an approach to that which involves vaccination and which is already in clinical trials. Actually, it's already in phase 3 of clinical trials, the last phase before regulatory approval. So everything's looking pretty good that way. But as I say, I don't think that's going to be a complete cure on its own.
Ladies and gentlemen, we have been talking with, learning from, and listening to Aubrey de Grey. He is the chief scientist for the SENS